Hello everyone, this is your first lecture of your chapter number 3, metals and non-metals. Okay, so till now we have covered chapter number 1 and chapter number 2. Chapter number 1 was about your chemical equation and balancing of the chemical equations and all, and chapter number 2 was about your acid, bases and salts. So chapter number 3 is basically about the metals and non-metals. Fine. So first of all, starting with the physical properties of the metal means if you want to differentiate between the materials, okay, whether that is metal or non-metal, so depending upon the properties, or you can say that the physical properties, how can you differentiate between metal and non-metal, right? So when you talk about the metal, so except mercury, okay, except mercury, all the metals are solid. And if you talk about the hardness, okay, so we have the exceptions of your lithium, potassium and sodium. Except these three, lithium, potassium and sodium, all the metals are hard in nature. Okay, now when you talk about the shining, means the shyness, so all the metals have metallic luster, means you'll see that thing in a form of your metallic shine, one kind is there, that will be present. Then depending upon the, you can say the malleability means that you can convert the metallic you can say the metals into the thin sheets. Okay, very thin sheets you can convert it. So metals are malleable, you can convert a metal into the thin sheets, in fact. Okay, now when you compare the ductility means that you can draw the metals into the wire. Okay, so metals have the property of ductility, malleability, they have the metallic luster, means they have they are shiny in nature, they are hard, they are solids. Okay, now when you compare the melting points, okay, so except gallium and cesium, they have the low melting points, although they belong to the family of metal. Actually other metals have a high melting point. Okay, now when you want to compare the boiling points, so metals have high boiling points. Okay, and when you talk about the conduction, heat conduction, so metals are good conductors of heat, in fact. Okay, and when you talk about the electricity conduction, so metals are very good in conducting electricity, and the best conductors are silver and the copper, and the metals are sonorous, means related to sound property, means whenever you hit the metal you will be able to see the sound. Okay, that is you can hear the sound from the metal, in fact. Okay, so these are the few properties that we see is concerned with the metals, means these are the physical properties that are concerned with the metals only. Now moving towards the properties of non-metals. So properties of non-metals, like that non-metals, now you can have the non-metals in the form of solid also, liquids also, or the gases also. So when you take the examples of solids which are not non-metals, which are solids in nature, then you have carbon, sulfur, phosphorus, etc. And liquid non-metals are bromine gas, and gases non-metals are your oxygen, hydrogen, nitrogen, etc. Okay, so these are the few non-metals that we have in the nature. Now when you compare the as compared to the metal, non-metals are soft in nature. Okay, as compared to metals, non-metals are soft in nature, except the diamond. Diamond is a non-metal, which is the hardest natural substance that we have. When you compare the lusterness of the non-metals, the non-metals, they do not have luster. So you see, actually in each and everything we have some exceptions as well. Okay, so in this you have the exception as an iodine crystals, and then non-metals are not malleable, means you cannot convert, or you cannot you can say hit the non-metals and convert them into a sheet. Okay, malleability is concerned that we have discussed into the sheets. Now the ductility is concerned with the conversion of your non-metals into the wire. So you cannot do it with the non-metals. Non-metals may be solids as well as liquids, and they have low melting point. Non-metals are solids and liquids have low boiling point as well. So low melting point, low boiling point. Okay, and non-metals are bad conductors of heat as well. Non-metals are bad conductor of electricity, and non-metals are not so much. So whatever the property that you have seen with the metals, non-metals have the property just opposite to that. Okay, now when you talk about the chemical properties of metals, so this is the reaction with oxygen. And when you talk about this, so reaction with oxygen, so when you compare when you keep the metals in the oxygen, then you will get the metallic oxide in fact. Okay, metallic oxide, like if you put the copper in then in the presence of air, you will get the copper oxide. If you put the aluminium, and when you heat the aluminium in the presence of oxygen, then you get the aluminium oxide. When you keep the means basically whenever you'll keep the metals in the presence of oxygen, you'll get the metallic oxide. Whether you put the metals and do not do anything, reaction may happen automatically, or some reactions require some kind of external energy to be provided to the metal to make the metallic oxide in fact. Okay, so this is the thing. So Ka plus O2 K2O and K2O plus H2O KOH. Okay, so these are the few reactions that you see during the conversion of the metal into the metallic oxide. Okay, so some metal oxides show acidic and some have the basic properties, and they are known as your amphoteric oxides. Okay, so metal oxide which show acidic as well as the basic properties, they are known as your amphoteric oxide. Example, like you have aluminium oxide, zinc oxide, etc. Okay, now moving to the next part, the reactivity of different metals with oxygen different. Okay, so every metal doesn't react with the oxygen in the same manner, or the reaction is not fast for all the metals. Some metals react slowly, some metals react very fastly. That's why the thing is that reactivity of different metals with the oxygen is different. Okay, like if you talk about the potassium and the sodium, so potassium and the sodium, they react very vigorously with the oxygen, and when you keep it in the presence of air, so it will catch fire. Okay, that's why we keep these metals like potassium and the sodium in kerosene to prevent the burning. Now if you hit the magnesium, then it will give you a bright flame. Okay, and if you hit the iron, then it glows bright. Now if you hit the copper, then it doesn't burn. Okay, in fact it doesn't burn, but it forms a black coating of copper oxide. Okay, and when you hit the silver and the gold, they doesn't react with the oxygen even at the high temperature. Okay, as I told, that's why I told you earlier that different metals react with the oxygen differently. Okay, depending upon their physical properties. So like some metals like magnesium, aluminium, zinc, lead, etc., they form an oxide layer over which prevents further oxidation. Means whenever you have the metal, so above the surface of the metal you will have the oxide layer, and this oxide layer further prevents the further corrosion, you can say, or the formation of the oxides, you can say, or the further oxidation of that very particular metal in fact. Okay, that's why we say that they are self-protecting metals. Okay, so in the next lecture I'll cover the next part of the topic. Thank you so much for watching this video.